Welcome everyone, this is your Lotico session on Next Generation RDF and SPARQL. We have more than 100 people joining us today, which tells me that there is still some life, or I may even say a keen interest in the topic of structured data on the web. After reviewing the list of attendees, I can see that many of you are experienced developers, professional practitioners, and senior industry leaders. So I think it's fair to say that you are all very familiar with the challenges and complexities that software and data projects bring to the discussion, and that they require us to constantly come up with a mix of well-established and novel solutions to address them. And that while we also have to deal with the ongoing technology and innovation waves that we can all experience every day. And of course, our tools have to continue to evolve at the same time as well. But make no mistake, despite the complaints and the frustrations we may have to deal with, we are all living already in a world of plenty and technological abundance. Since I first began exploring the themes around RDF and the semantic web more than 25 years ago, and I may have engaged even longer with RDF-related topics like XML before it was widely associated with the W3C semantic web activities, RDF has come a long way. Today, we can look at a much more mature landscape of tools and standards that empower developers and practitioners to create robust, structured data representations for content enrichment and business logic implementations for large-scale distributed applications. Throughout the years, there have been many attempts to reimagine the semantic web vision, including the introduction of concepts like linked data, Web3, semantic wikis, knowledge graphs, solid, fair, and applied data models such as property graphs that supposedly may align more closely with the traditional developer domains such as graph theory and database systems. Lotico has been actively engaged in many of these efforts over the years, and Lotico may have even helped to shape some of them to a certain extent by focusing the community's attention on these specific topics. Today's Lotico presentation is no exception. I'd like to trace the topic for this session back to Lotico presentations from 2020 featuring Holger Knubloch, who is also scheduled to be with us today, and his persistent efforts to establish new frameworks based on core RDF standards and tools to improve data management in RDF projects, particularly through the Data Shapes initiative and now official standards like the W3C recommendation SPARQL. I also would like to mention Jose Emilio Larragallo and Eric Prudhomme and their work on checks and their presentation to the Lotico community in 2022. And the efforts to redesign RDF annotations by enhancing metadata level support that goes beyond the standard name graphs and reification patterns that we are all familiar with to RDF star and SPARQL star extensions that were championed in 2021 here at a Lotico event by Olaf Hartig, who I believe is also with us today along with Pierre-Antoine Champin. I see today's presentation in this tradition and as a continuation or perhaps even a culmination of these efforts in the development of the new RDF and SPARQL 1.2 standards by teams under the umbrella of the W3C. While the proposed changes may sound somewhat unassuming at first, they actually represent the work on the next generation of RDF and SPARQL standards, which may fundamentally influence how you will work with RDF and SPARQL in the years ahead. I would like to welcome Niklas Lindström and Andy Seaborne, both active participants in the W3C working groups. Niklas is a data practitioner at the National Library of Sweden and serves as a co-chair of the Dublin Core Metadata Initiative Usage Board and is an editor of the W3C RDF 1.2 Primer Working Group Note. Andy, of course, is a well-known open source developer and chair of the project management committee of the Apache Software Foundation's top-level project, Apache Jena. He also serves as an editor for the W3C RDF 1.2 Concepts and Abstract Syntax Candidate Recommendation. Niklas will speak for about 40 minutes and is followed by further updates from Andy. Once the presentations are given, I will open up the floor to the Q&A for about 15 minutes and possibly have an all-open chat afterwards. The event will be closed in about an hour and a half. With that, I would like to ask Niklas to come forward and take to the stage to take it away.
Thank you, Marco, and thank you everyone for joining today. I'm very proud to be here and presenting with Andy. I'll just start by sharing my slides. That should do it. Does it look okay? I think so. So today I'm going to talk mostly about the new style reification, which the additions to RDF 1.2 will enable. There have been lots of improvements to RDF 1.2 and there are still work on that. RDF 1.2 is still in a working draft stage, and although the working group has been charted to 2027, we are closing to a state of candidate recommendations for some of the documents. And this presentation will focus mainly on using triples as objects to enable a new style reification. So I won't talk about the other additions. Andy will mention a bit about them, but we'll also mostly focus on the things in SPARQL that are done to adapt to this new way of reifying abstract propositions. Before we go into how that works, I just want to clearly look at what we have in RDF and have always had in RDF, which is the simple triple. The simple triple forms a logical proposition, which when it is in a graph and the graph is interpreted, a graph is defined as a set of triples. These form an interpretation, so these represent facts in an interpretation. That is very simple and very powerful, and it has enabled us to do many things and describe all kinds of domains. There are some things with this simplicity that may be challenging in certain circumstances. We have use cases surrounding various kinds of provenance, data provenance or knowledge provenance on different kinds of granularity. We have usage patterns akin to various forms of qualification, where you want some kind of more n-ary relationship of some kind. And you also have situations where you want to represent suggestions of some kinds. So talk about propositions without them necessarily being true. The traditional solution to that has usually been that you change your modeling somehow, that you do more granular remodeling of your description of your domain. Things like the provenance ontology are examples of that, and the old style or classic reification is another kind, which is an informative structure, which is not normative, but it has always been with us in the RDF specs. Still, technology advances, and on the scene since for quite some time, we have had the notion of labeled property graphs, with the flagship implementation usually being Neo4j, which is another kind of approach to graph data. It might superficially look like what we think in when we use RDF, but there are important differences. One of the things that this technology has that has been sort of wanting perhaps for certain use cases is the ability to set attributes on edges. In this case, we have a simple bought relationship between Alice and Lenny the Lion, but it also has a date attribute set on it. To meet that, there have been various approaches. One of the most prevalent ones has been with us for, well, more than a decade now, known as RDF star, which Olaf Hartig laid the foundations of in a paper in 2014, if I am not mistaken. There have been iterations upon that, publications, and there was a community group formed in 2020, which published a report at, I think, the end of 2021, which evolved this. It had an additional syntax, which made a bit of a difference, which we will look more into soon. And this led to a lot of feedback, a lot of emails, and a lot of GitHub issues and discussions. And a working group was formed in 2022, which set the path to standardizing this. And the goal, although we're charted to 2027, the goal is to, during this year and in the next year, ensure that we have a stable standard, that RDF 1.2 will include support for the notions that come from these concepts. But this will no longer be called RDF star, it will be called just RDF or RDF 1.2 specifically. It is important to recognize that although the designs that we've seen in labeled property graphs sort of look like RDF at a glance, there are crucial differences in what it means. Actually, as far as I know, there are no model theoretic semantic standardized for labeled property graphs to this date. And thus no way of doing formal entailments. So this is not based upon the same fundaments as RDF is. Another interesting and important difference is that the edges in the labeled property graphs are unique, even if they are labeled with the same, in this case, bought label. So you can have what, from an RDF point of view, is a multiset or a bag. So it's not the fundamental definition that RDF has of a graph, where a graph is a set of triples. So if we use the syntax which comes from RDF star to represent this, you might already see the crucial difference here. The key thing is that the triple is unique. So in order to represent the use case that we've looked at here, where you have two occurrences of this proposition, you need to have unique identities for it in order to be able to represent that in RDF. Otherwise, you would smush them together and you couldn't see the difference between these occurrences, which have different dates, and they pair a seller with a date. You could assume that these might be purchase entities in a domain. This means that a triple and the proposition that it represents is an abstract thing. It is not itself something more concrete. It is a logical proposition, and that is key. Anything more concrete has to relate to that somehow. You can see that from another perspective. You can think of descriptions as being maps, and with a well-known phrase in knowledge representation is that the map is not a territory. I think it has its own Wikipedia page, so it must be true. Well, it's pretty obvious, and we know that maps have different granularities. They are representations of something, and the level of the abstraction sets certain limits. So it's very hard to zoom in on something and keep the same abstraction. You realize that what is a simple connection on one level is a multitude of connections on the more fine-grained level. And furthermore, you can have entirely different abstraction models which lack some of the important information in other abstractions. Yet they do share similar notions. There are entities here that we refer to in the same ways, but on different levels of granularity. With that in mind, let's now look a bit at what is defined in RDF 1.2 as the concepts and the semantics. What we will have with RDF 1.2 is the ability to use triples as objects of other triples. So they can work as terms alongside the IRIs, the B nodes, and the literals. This means that they denote something in the interpretation. Specifically, they denote these abstract logical propositions, independent of their truth values. So the triple, when used as an object, refers to what the meaning or the sense of the relationship is, not its truth value. In some ways, you can compare triples as terms as literals that also denote something in the value space of the data type with which their lexical representations are paired. They are very different things, but both of these are usable as objects in descriptions in RDF now, and they denote something through their structure. More formally, a triple denotes the set of propositions, which has a defined IRI in RDF schema. And semantically, these are sometimes called a transparent semantics. So they denote the sense of the relationship. These are not encodings, which you can have checksums of and something like that. That would be a data token of this proposition. And it's still the case, of course, that if a triple is in the graph, this is an encoding. The graph is an encoding of an interpretation, and the triple is then a fact in the interpretation, which is this is the only part of the semantics document that I will show, but there is a formal definition of what this means in an informative section so that you can understand what a set of propositions is and that the set of facts in an interpretation is a subset of the set of propositions. There are much more details around that in formal semantics, but I won't even explain the notations fully here. We can go into that, or you can look at the semantics document where this is furthermore explained. And then we have the notion of a reifier, which is anything that relates to a proposition, which is described using a triple which has as a predicate RDF refis, which is a new property defined in the RDF vocabulary that has a proposition as an object, meaning that you use a triple term as the object value of RDF refis. And the subjects, the refiers, they can be anything depending on what you need to model. So you use your own domain of discourse and you define what these things are. They can be circumstances, situations, and events or periods of time of various kinds, or data tokens, or something related to provenance. Now, this is not the only design that this working group has considered, and there have been a lot of work going on for many years tackling these notions from various angles. Of course, we have the classic reification, which simply describes one of these kinds of refiers, which is a reification of the triple itself, conceptualized as a token that is described using 3 properties. This has been more or less proven to be very unwieldy and sometimes misunderstood and hard to use in various cases. Some of the other cases have just used end-array relationships and remodeled, as I mentioned originally, and we will look a bit more on that. I will also mention how this conceptually and formally relates to the notions, the definition of named graphs in datasets in RDF. I will not go into the design of singleton properties or using the triples to denote subjects and describe those, nor the notion of named triples. There are lots of discussions about that. You can perhaps dig some of them out from the mailing list and the GitHub threads, but I will not mention them more until we get to the Q&A, depending on where you want to go in that. This is the foundation explaining what the syntactic sugar that we looked at from RDF star now means. So this is a form of syntax which is called annotated triples. And here I do not put anything meaningful in the annotation. I just say that it's a resource, just to clarify that it can be anything, basically. The key here is that what this syntactic sugar expands to is this, 3 triples. First, the asserted triple itself, the simple relationship between Alice and Lenny the lion. And then we have the resource here, a blank resource, so we haven't named it. And it is related to the proposition that we also know is true in this interpretation, using the RDF refis relationship. This latter form is not expected to be used in the turtle syntax or the trig syntax, but it is how this is encoded in n triples and n quads. The annotation syntax is for the users, so this is what you read and write in turtle. There is another syntax which has always been around since RDF star came along, which is called a refined triple. And in this case, we describe a statement of the proposition without asserting it's true. So perhaps someone doubts that the Earth revolves around the sun or doesn't know that, but just want to describe that Galileo was the source of this statement in 1610. So this also expands to something very, well, the same thing as previously, but without the assertion of the triple. So we have 4 triples here. We have a refier, which is typed as some kind of statement. We might use the classic reification vocabulary as the type here. And then you have the properties the predicates of the blank node source and date, and it relates to the abstract proposition using RDF refiles. You don't have to use blank nodes. There is a syntax for naming the refiles too. In the first case here, we see what we just saw, a statement for, or in this case, something which is a transaction, and the unasserted triple. And in the second case, we have a named annotation. You can actually combine that, but it's usually flatter to do it like this, to name the annotation and then describe it further. That's something I've used fairly much now at the National Library of Sweden to work with correlating information. And I tend to use the metaphor of footnotes or marginalia when I discuss how we can use this in our domain of discourse. So this is something we've seen in text, I suppose, all our lives, footnotes, which relates to something. And in this case, we have that fact that Earth revolves around the sun, which I say and then annotate that Galileo proposed, and it was considered something blasphemous a long time ago. And nowadays we have a view of it which says that it is true, but you have to define a frame of reference in connection to that somehow. So you have more detailed circumstances of very different kinds surrounding this, which is encodable using this syntax in the following way. So the same thing, a simple triple, a simple proposition. It has three annotations which are named by relative IRIs. And they have different types, and they are described very differently. That was one of the many modeling patterns that this enables, and now I will go into some other ones. We have already seen that you use RDF type, as you usually do, to say what set of things the resource that refiles an abstract proposition is, which enables us to do a lot of things. And these notions have been around for quite some time. We have the class clarification again. We have the provenance vocabulary, which has qualified notions of many of its simple relationships. And we have schema.org, which has a role concept. We also have the bib frame ontology, which I work with a lot, again, in the library sector, which has more qualified definitions for more concrete circumstances surrounding some things that usually is described more simply using the Dublin core ontology or vocabulary, for instance. So this is the same example, a bit more fleshed out, where we have the relationship and we describe it in this case more further, it has a transaction source from which we have inferred it, perhaps, and it has a source and a timestamp. Another domain might want to describe this instead more concrete from another perspective, talking about a purchase with a seller and a date. Or, as we saw in the beginning of this presentation, you have multiple concrete purchases and the abstract fact that Alice has bought this product, but she did so at 2 different times in 2 different places. A very rich source of structured data which you can look at from this perspective is Wikidata, where you have lots of provenance and qualifications surrounding simple facts. This is since Wikidata was around long before RDF star and RDF 102, this is not how it is modeled today. It is more closely modeled to how the provenance vocabulary or ontology has designed it, meaning that it has simple relationships and then more qualified relationships. So you have a redundance of description there. But what is now enabled is that you can keep the simple descriptions and then add qualified information pertaining to that. So this is a real example of data from Wikidata. You can pick out the name and look it up. I have made some tooling to reduce that using RDF 102, but I won't go much further into that now, just noting that this design works to simplify how you approach these problems. And now we're veering a bit into more advanced patterns utilizing this design. I continue with the Wikidata example, adding some more detail that I got from the description that we just looked at. We have these education periods culminating in academic degrees, and these are in turn described by records in some source. And we can annotate this, and in this pattern I use the same reifier to reify multiple propositions. So I use the same identifier for reifying the described by information pertaining to the education period. And this reifier has the same data file and a timestamp recorded for when it was retrieved. So this is again a case of using data provenance, but in this case you have a reifier of 3 propositions. This is not immediately obvious if you look at the simple use cases, but it is quite common that simplified relationships can sometimes need more contextual detail. We certainly know that. And different modeling choices lead to very different perspectives and very different kinds of predicates used. So although in the simplest cases, you only need to reify one simple proposition, there may be cases where you do have to use multiple propositions at once. One very simple example of that is that if you have modeled names of persons using only one property called name, you can get by with a very simple reifier if you want to say something about the provenance of that information. But if you have instead used 2 properties for that, given name and family name, you can still reify that with the same provenance information. Another case which utilizes some of these features is a case which I've come across recently and recurrently because I've seen it many times before. If you have very simple relationships from a text to an author, you have the author relationship in this case, but you want to describe that this author was affiliated with an institute of education of some kind. It's very hard to do so because it doesn't fit in this simple model. You can say that the person is affiliated to a school, but if you have multiple people, multiple authors of a text, what do you do? Well, traditionally, remodel. And this model is how BibFrame would represent the same structure. So you do a more granular modeling where you have a contribution, and then you put the agent, the date, and the affiliation as properties of that contribution instead. But with this feature in RDF 1.2, you can use an annotation on the simple relationship instead, meaning that nothing would change for users of your dataset. You can keep the same simple relationships, but you can add the additional detail later on when you realize that you need it. Still, you might actually already have an affiliation on the person. What do you do then? Well, you can reify that using a reifier of two triples, of two propositions, so that you can pair them together. You can say that the first contribution pairs the affiliation of Alice with the authorship of the first text. So this one here and this one here. And same thing for the other ones that are color-coded, so that you can have, in the other case here, you have two authors, and the second author you describe more granularly with the role of the contribution. It was the author, the writer of the introduction and the writer of additional textual information. So you can use this to keep a very simple model with very flat relationships and still amend that, if you will, or augment that with additional facts. The same thing can be done if we have the original example we looked at with the bought relationship, but instead of adding the information of a seller, perhaps you had another data model to start with, where you already have a sold relationship present in your data and usage of that, so you don't want to remodel that. And in that case, you can use the same additional information of the date when this occurred, but you can use the reifier to coordinate the simple relationships instead. Now this pretty much begs the question, it begs two questions actually, but I will take them sequentially. Why don't we just use the n-ary relationships? Well, I hopefully have already sort of explained that it's too late because we are in production and we have the simple relationships. So although this would, from certain perspectives, definitely be a much better way to model your data, and I would agree with that, but it really depends on what level of granularity, what zoom level of your map that you started out with. So this isn't always what you can do. And if you have OWL, more advanced reasoning upon RDF, you can of course say, well, I don't need any of this because I can entail the simple relationships. And if you can, that's perfectly fine, that's great. Then you have no problem here. But it's not the common case that that's what you can afford or what you have in production. So what we have here is another way of keeping the simple model and achieving more or less the same results. And although this will not become a part of RDF 1.2 because OWL is not RDF 1.2, I am working on a note to explain more about how you can relate these designs, and you can use OWL to entail from both ends of the perspective, but I won't go into that today. So, and probably not in the discussions either, because that's an OWL Q&A. But if you're interested, please contact me. And the other question is, well, this reminds me of named graphs I've heard a lot, and I tended to agree with that from certain perspectives, but there are crucial differences here. Well, the obvious one is that there is no defined semantics for datasets. And the fact is that the working group wasn't charted to define any such semantics, so it wasn't an option. But still, we discussed and explored what it would mean in various perspectives. And it doesn't really work out anyway. We do know that the name of a graph doesn't necessarily denote the graph, it's undefined. A name graph is actually a pair of a name and a graph in a data set, which can also have a default graph. And this structure is not nestable. Also, and more crucially, they are complementary designs. So you can have a name graph with refires in them, or you can partition that differently. So they are not alternative designs, they solve different problems. Another thing that is very important to recognize is that it might remind you of a graph if you have a reifier of multiple triples. But a graph is a set of triples, and this reifier doesn't relate to the set. It's easier to see what I mean if you look at just basic RDF, and you have two relationships with the knows property. Alice knows Lenny, and Alice knows Bob. But that doesn't mean that Alice knows a set. She knows each person. So the relationship is something specific. It's not a set. The result of a query on that might be a set of Lenny and Bob, but that's a different thing altogether. And in the same way, a reifier reifies each proposition. And a set of one triple is not a proposition. A triple denotes a proposition. So there are very different notions going on here. And one of the key things is that there is a path here, and there is a path here. And this is not the same thing if you have a name graph, a set of triples. So they are very different designs, and they are complementary. In practice also, name graphs are used for graph store management. We have linked data protocol, and we have many implementations of the graph store protocol. So they serve different use cases. And another way to think about it is that when you manage your data, you're sort of outside of these notions of semantics and interpretations. So you're looking at the painting, not the pipe, if you remember the old Magritte analogy that we've used a lot in RDF over the decades. Whereas the reifier is everything, the denoted propositions are all inside the interpretation. That's what the transparent semantics is about. So these are very much complementary designs. There is more to this story. There are very interesting features that are now enabled that we have only begun to explore. Since triples are now usable as objects, you can use triples and triples and triples. That is not what a reifying design is about at all. We have a very simple approach to that, and the syntactic sugar uses a relationship defined in RDF to make things simple and usable. And there are aspects here that we will not explore much further, but it is a possibility. Some of us have been discussing a bit about modal logic, for instance. It's also very important to know that the triple structure is not cyclic, so you can't have contradictions like this proposition is false or any other abhorrent logical problems like that. And in summary now, the final slide, what we have now with this is triples as objects. They reference propositions, And you can relate from reifying circumstances to these propositions using the predicate RDF reifys. To make that usable and ergonomic, we have syntactic sugar in Turtle, in SPARQL, and in Trig, and also being worked on for RDF XML. And in another working group, which I'm also part of, in the JSON LD working group, we are working on this too. So you have the annotation syntax, the blank node form, and the named form, and also the case when you do not want to assert the fact, you have the sort of quotation style syntax as well. And the reifiers of these abstract propositions can be of any type you need. So the classic reification style or any of the more qualified designs that we've seen in the wild are possible to follow design-wise using a much simpler approach where you do not have to define companion qualified properties for any simple relationship. You can instead use reifiers and the annotation syntax to achieve the same results without changing your application. And that's all. Thank you.
Thank you, Niklas. And we're, I think, moving directly into Andy's presentation. And we will have the Q&A after Andy's presentation.
There we go. So following on from what Niklas talked about, there are that, I mean, the verification work has been the main focus of the working group, and that has some follow-on consequences for SPARQL. There's also a couple of areas that the working group has also been working on, and also looking at a little bit about the transition from RDF 1.1 to RDF 1.2. So we've got the new style reification. The core of a SPARQL query is, in a sense, turtle with holes in, and that style has been continued. Basic graph pattern matching, which is where variables are associated with values from the graph, remains as simple entailment, which gives the connection between an algorithmic matching pattern with the logical consequences of the entailment and the extension point that different entailment regimes can be used at that point to give higher levels of query access with semantics. The syntax follows RDF 1.2, and I've got some examples in a moment. And then there's some functions that relate to manipulating the triple term objects, which as you can create them for results in construct or in update. You can ask whether it's a triple term, and you can access the elements of the triple, whether subject, predicate, or object. There are also consequential changes to the result sets so that it flows through the through the whole of the set of SPARQL specs. I'll jump to the last one, the initial text direction, which Niklas briefly touched on. That's something introduced by the working group. The requirement was established within the JSON LD working group. What the RDF and SPARQL working group has done is made syntactic changes to literals to give the ability to specify the initial direction of a text fragment, which was not available to the JSON LD working group. They have some proposals based around data type and composite language tags, but this working group had the scope to make some syntactic change. That has consequences for some of the functions. You can ask whether something's got a language direction. You can access it. There's a term constructor, but also the operations that were applying to RDF langstring also now apply to RDF der langstring. So the direction of the text as specified is treated as an additional component to language strings. There's been, on the SPARQL side, a fair amount of work to bring the documents up to respec and reformatting, since actually SPARQL 1.1 is actually slightly older than Turtle and wasn't a respec document. And there's work going on around various errata that have accumulated over the years. The last part applies to both RDF 1.2 and to SPARQL 1.2, is to consider how these syntax changes can be more smoothly deployed across the web. It's unlikely that everything will change rapidly. The change from around previous versions shows that every time you come across another version, it's actually slower for adoption than the last one, which is fairly natural. There's a lot of investment in RDF 1.1 and similarly SPARQL 1.1. So there's a version indication and a mechanism to at least state that it's 1.2 material that may be in a request or in data response. So these two queries are, the first one is the annotation syntax that Niklas talked about, and like Turtle, that is syntactic sugar. It is expanded internally to a bunch of triples as described in the query below. So the only thing that impacts a triple store in terms of storage that it needs to be able to handle is this new term, RDF term type for the triple term. That's the only change to the RDF data model. Not that there are changes in semantics, but the data model has introduced this new term. Similarly, there's an introduction for the text direction on literals, but this is a new term type that has 3 components. And the matching will proceed in the same way as before, whereby if you consider that to be a pattern matching problem, it's equivalent to simple entailment. The other syntax forms are for triples which may or may not be asserted in the graph, just getting their reifications, and then to restrict it because you've used pattern matching to a certain subject. You could write the subject in place if you want, although that wouldn't be returned in the resulting query. Or you can write to actually access the RDF reifies triples in your data. And in this case, there's a function to pull out from the triple the subject and provide a restriction there, achieving a similar task. So at the SPARQL level, the consequences are the syntax and the changes to the triple storage model. For the migration to RDF and SPARQL 1.2, the working groups introduced the notion of a version. It's not mandated, and it occurs as a way of recording whether the data is 1.2, whether the top example here is in Turtle. You've said the data may contain triple terms or initial text direction. And SPARQL has the same form. There's a version. RDF XML and all the syntaxes where it's possible to include new RDF level syntax has it. So N triples is more of a, it's not an N quad is not so impacted because it doesn't have a way of having keywords. But the other place it can come in is as a media type parameter. So you can do content negotiation. You can say you accept TextTurtle of version 1.2, and you can publish data with content type version 1.2. There's also a sense of future proofing as well. The mechanism isn't only for the migration of 1.1 to 1.2. It gives us a way of putting in future syntax changes as they may come along in the future. And the RDF 1.2 working group is really putting the mechanism in place now because it's an opportunity to. What it doesn't specify is what happens if there's a mismatch, because how you deal with that will probably depend on the situation in which you are supplying your data. One possibility is HTTP 406 doesn't match. A content negotiation is only ever a suggestion. It's not you are obliged to only exactly meet a set of requirements or exactly, a set of requirements. And due to streaming anyway, if you are outputting a large data set, large amount of data that doesn't fit conveniently in memory, all you can really do is put the notification in that it may contain triple terms, because the consequences of looking at all your data first before sending it back is a significant impact on performance that may not be practical in many situations. The working group has also been looking at a suggested basic encoding of triple terms, colloquially called unstar, although we're trying to say less about star and more about saying it's RDF 1.2 basic. And the system may choose on a request to get TextTurtle version 1.2 basic to perform that transformation on the data. It's not completely semantics preserving. It's not identical semantics, I should say. It is reversible. You can rebuild the original input with triple terms from the basic encoding. But I think that provides you with the way forwards, particularly for obtaining data that will then work within an RDF 1.1 toolchain. The other way of dealing with mismatch is just have a syntax error. We're on the web. Things go wrong anyway. We're not providing anything from doesn't exist to just syntactic errors in the published information anyway. So systems really will be already dealing with the possibility to provide robust user application capabilities. But we have done some experimentation around adding the version media type parameter, which the specs say you can add and it shouldn't affect anything else. And we've confirmed that with many of the available RDF toolkits, it does perform in that way. So you can feed this stuff straight into existing ones and then ignore the stuff and then treat it as a syntax error, maybe abort a database transaction if you're loading that locally. Each of the labels has a meaning. There's version 1.2. That means 1.2 syntax, 1.2 semantics. Basic means without triple terms. but possibly with initial text direction. And there is included a 1.1 label, which implies that except for the version directive, the data is in 1.1 syntax. But in particular, it is conformant to 1.1 semantics, not 1.2 semantics. RDF 1.2 semantics is actually just a superset. It doesn't change anything in 1.1. All 1.1 data or 1.1 SPARQL queries will perform the same on RDF 1.2 systems. The semantics adds some more axiomatic triples and the interpretation of triple terms. So, but it does mean we now have a metadata statement for archiving and future and recording on data you have, what it conforms to. So the changes in SPARQL are consequential from the work that's been done on RDF, and there's a framework in which to migrate systems from 1.1 to 1.2 that provides the information available, and we hope that it'll smooth over the transition. Thank you.
All right, thank you, Andy. I think this concludes the presentation section, and I would like to open up the floor to the Q&A.
I have a question. Thanks, Niklas. Thanks, Andy. Could I dig into the semantics of reifiers a little bit more? So is a reifier something distinct from the proposition that it reifies, or is it supposed to be another name for the same thing?
It is distinct, very much, yes.
Okay, cool. Yeah, yeah. I had a worry if it wasn't the case, but is now moot, so thanks.
Great.
Very good, Matt. All right, more questions, please. Okay, is this another Matt or is this the same hand?
Sorry, if that was me still with my hand up.
All right, Pavel, do you want to go ahead?
Yeah, I was just looking for a hand, couldn't find it, but I can just ask the question. So what is there already a publicly available data set using RDF 1.2? Like what's the largest one out there?
There can't really be because there is no 1.2 yet, but
Yeah, but like, I'm mostly asking for some kind of benchmarking purposes.
right, yeah, I understand. I don't know of a sort of production size. I know there are RDF star things out there, but I don't have a reference readily at hand. I do have my experimental convert all the Wikidata to RDF 1.2, which I showed you a piece of, but that's, I think I have a branch of that, so I shouldn't send you the link yet because I need to update parts of that. But once I've had time to do that, you could have all the Wikidata using RDF 1.2 as a benchmark suit.
Okay. Thanks.
All right, Michael Usholt. Please unmute yourself and.
All right, yes. Question, can you hear me?
Yes, very well.
Great. Very good presentation, thank you. A couple of questions. One, is there any implications on Shackle?
Shall I answer that? So the Shackle, there is a Shackle 1.2 working group currently active. It's not 1.1 Shackle because part of its charter is to put in features for RDF 1.2. So they are there is work going now to align SPARQL with the changes coming up from RDF.
Okay, thank you. The other thing was, to what extent is this a convenience thing, which just makes it a lot easier to do things versus you can now do things that you couldn't do before?
I would say you can do something that you couldn't do before because you can explicitly and formally reference a proposition directly, which is different from what you could do before, because the classification could only describe a token of such a proposition.
That's something that a theoretically inclined person will appreciate, but a business person building and using knowledge graphs, will they notice something that they can now do that they couldn't do before very easily?
That's the important question, definitely. Well, yes, in the sense that you can now start with something that you then later on realize was too simple from a new business demand. And without rewriting any queries, you can add more detailed, granular information about circumstances surrounding the simplified descriptions.
Thank you very much. Good presentation.
Thank you.
Thank you for joining us. Wolfgang has a question.
Yes, I have two questions actually. So one is about whether a statement is asserted or not. So with RDF star, there was some discrepancy, or database vendors implement this differently. Like Stardock would always assert a statement if it was mentioned and GraphDB not, or the other way around. I forgot which way around it was. Is this now kind of clarified depending on which syntax you use? Because my understanding was if you just use the syntax as it was specified with RDF star, it's not asserted automatically, whereas if you use this curly brace pipe notation, then it was also marked as asserted automatically.
Yes, this is fully clarified now. I think originally there was something called PG mode and the separate assertion mode, SA mode. That's no longer the case. I think even the community group report fixed that, clarified that, so that the double chevron syntax is for describing without asserting, and the curly braces is for asserting and then referring to that from a reifier.
Mm-hmm. Thanks. And the other question is, we had some version statements in both SPARQL files and Turtle files. Would that mean that those syntaxes that were presented are only, let's say, active if those version specifications are there, and otherwise it would fail by some compliant parser?
That depends what your parser is claiming. There's no need to support version, particularly I think on the SPARQL query side, because that's a query is more transient than your data. So it's more important knowing what your data is and what so you can run a SPARQL 1.2 system on RDF 1.1 data, and it'll behave like 1.1 data because you just won't touch. We haven't changed RDF in a way that has whole system effects. I think also with the data, because it's longer lived, it's important to record what it is claiming, so that in the future, when you take the data out of the filing cabinet or whatever again, you actually have a new piece of information to record about its metadata, because often metadata can get separated from the original content. You don't have to say that you're going to use 1.1 or 1.2. If you do, you can discuss with your software providers about how they deal with that. And I think in different situations, there'll be different ways of handling it to what's appropriate. You might want to have a system which is strict in what it produces and lax with what it will receive. You may wish to have a system that is strict on both in and out. It really depends what level you want to make your system robust and appropriate for the purpose that you're dealing it with.
Thank you.
Thank you. And Wolfgang, since you only use your first name, could you briefly introduce yourself?
My name is Wolfgang Schell. I'm a software architect at MetaFacts.
Very good. Thank you very much. And more questions, please. While people contemplate their questions, now I have a question. Might be very basic, but what is the significance of text direction? Am I missing something here, or is this just a fun example?
Well, it was established in the JSON LD working group. The problem with data is, well, there's several aspects. While language tags can imply the script that's available, most data does not say which particular script it's written in, which is a problem for, because many non-Western European languages have both a script in left to right. They might all have a right to left form as well. Or in one case, there's a country which has 3 different scripts. And there is an algorithm in Unicode for determining what you should do, but it's not perfect. Close to home, the thing that it's really bad for using automatic determination is identifiers, telephone numbers, ID codes for things, because they will often not have enough information to determine what the display direction is correctly for them. And if there's a risk that they get reversed when they're displayed, then they would be a different identifier. So it's a robustness thing in some cases.
I see the point. I have Suripira Das asking a question in the chat. I'm not sure if he can see it. Maybe he wants to unmute himself and pose the question on the microphone.
Yeah, I'm actually part of the RDF 1.2 group. So I was just curious about this because I was not sure if we had 2 of those SPO in the turtle notation, whether that implicitly says that there should be 2 distinct blank nodes or not. So I see that Niklas already said yes. So
yes,
that's good. Okay, thanks, Niklas.
Thank you.
Very good. All right. Is there another question on the Q&A now? If not, I will stop.
I didn't raise my hand, I guess.
Sorry, yeah,
but I had one other question. Okay, so and this question is for SPARQL. So Andy, basically, suppose I have, Niklas mentioned about the nested triple term, right? So if I had a nested triple term, and let's say I have a variable there in the SPARQL triple pattern, right? So I have, let's say, SPARQL triple pattern says SPO question mark O, and the O actually matches a nested triple term, right? So it returns that as a triple term, which happens to be nested. Is there a function or something that we would like or the user would like to say that, okay, I want the 3rd level subject in the 3rd level of nesting, right? So like a 3 comma subject, let's say, is the argument of the subject, as opposed to trying to get the term by having to explicitly provide a structure until the 3rd level to pick up the S from the 3rd level. Could that be like a convenient kind of function?
If I understand your use case, then the answer is yes. You can do the SPO question mark O and then use the functions to get the elements of any triple term there, and functions nest. so that you can then ask for levels further down.
Okay, so if I say like, oh, 3 comma subject, that will basically indicate that to the system that, okay, I want the third level in the nesting, and I want the subject component that is present at that level of nesting.
Yeah, there's no syntax to help that. And when you go back to Niklas's presentation, when he's talking about propositions rather than actually having the triple terms themselves, the working group thinks that nesting will be unusual because normally what you're talking about is the proposition, and you may be referring to another proposition, so you'll be referring to its reifier and not the triple term.
Right. Okay, thanks.
Hey, Michael or Short?
Yes, I was very interested in the discussion in relating this to named graphs. One of the things, but we use them named graphs all the time, they're very powerful, mostly for loading things so we can swap them in and out conveniently. But the problem with named graphs, aside from semantics, is you can only use them for one thing. So it occurred to me that if you can tag a triple, I can get the effect of a named graph by tagging like 500 triples with ng1 using RDF star, and then I can have the same 500 triples. 200 of them could be in another graph along with some other triples. So I guess the question is, to what extent, it looks like to some extent I can use this facility to achieve similar but enhanced functionality that I got with the name graph. Can you comment on that?
I would say a very conditional yes. And the condition is that people, including myself, have probably tried to use named graphs to achieve things that they didn't, as you also mentioned, semantically work for. So if we didn't have named graphs, what you're seeking here would be enabled by this without a relationship to the concept of named graphs, if you see my point. So
yes,
there are things that are achievable here on conceptual levels with even nesting that isn't simply possible with the mechanical, if you will, design of data sets.
so it would be possible to do what I suggested. The question then becomes, is it practical? It might be clunky and inefficient to implement that.
That's a very good question.
No answers yet. Thank you.